In this module, we will discuss the air conditioning system. We will start with the system description and follow with the discussion of the associated controls and indicators. We will conclude with a review of normal procedures. The air conditioning system consists of a left and right pack. They convert pneumatic air into conditioned air to maintain selected temperatures throughout the aircraft. A distribution system provides equipment cooling as well as increased ventilation rates throughout the cabin. Air from a ground air conditioning cart can also be used to cool the airplane. We will now start with the description of the air conditioning packs. The air conditioning packs convert hot, high-pressure pneumatic air into conditioned air. The sources of air for the air conditioning system are the engines, the APU, or a ground pneumatic cart. Hot engine bleed air flows through the pack valve and passes through a primary heat exchanger. This heat exchanger is located in a tunnel within the bottom side of the fuselage and is cooled by slipstream air. This slipstream air enters the heat exchanger tunnel through movable ram air doors. After flowing across the heat exchanger, the ram air exits through the ram air louvers located aft of the heat exchanger. In flight, the ram air doors modulate open or close to provide the required airflow for cooling. When the flaps are extended in flight or on the ground, or any time maximum cooling is required, the ram air doors and exit louvers are fully open. The full open light on the air conditioning panel illuminates. During low airflow conditions, such as when the aircraft is on the ground, pneumatically operated turbofans draw air into the heat exchanger tunnel. This increases the airflow around the heat exchangers. The turbofans operate anytime the flaps are not retracted or when the air-ground switch is on. After passing the primary heat exchanger, the pneumatic air enters the compressor section of the air cycle machine. Then, the hot air is cooled by flowing through a secondary heat exchanger. The secondary heat exchanger is also located in the heat exchanger tunnel. After passing through the secondary heat exchanger, the air flows to the turbine section of the air cycle machine. As the air leaves the turbine, it is expanded, causing a drop in air temperature. The result is cold air. This cold air passes through a water separator, which extracts moisture from the air. The pack output temperature is modulated by mixing it with some hot bleed air. This air is tapped immediately after the pack valve and flows through an air mix valve. This hot bleed air and the pack output air are mixed in a mixing chamber to produce conditioned air. This conditioned air is routed into a mix manifold where it is mixed with the output from the other pack and enters the distribution system. A ground air conditioning unit can be connected directly to the mix manifold. The aircraft is divided into two air conditioning zones, the cockpit and the passenger cabin. The left pack's primary purpose is to supply air to the cockpit, but it also directs the remaining air to the mix manifold. The right pack supplies conditioned air to the mix manifold. The air from the mix manifold is distributed to the left and right side of the passenger cabin. The duct temperature for all three distribution ducts are monitored. An excessive temperature within the duct will cause the respective duct overheat light to illuminate. The air conditioning annunciator light and the master caution light will also illuminate. A duct overheat will also shut down the corresponding pack. The pack valve will automatically close and the pack trip-off light will illuminate. A recirculation fan draws cabin and E&E compartment air into the mix manifold through an air filter. This improves ventilation rates and reduces air conditioning pack load and bleed air demand. The end result is a reduced fuel consumption. The fan is controlled by the recirculation fan switch and operated with AC power. The recirculation fan will operate only if the recirculation fan switch is in the auto position. With the recirculation fan switch in auto, the fan does not run when both packs are operating and one or more of the packs is in high. The controls and indicators for the air conditioning system are located on the overhead panel. Each pack is controlled by a 3-position switch: off, auto, and high. With the pack switch in the off position, the associated pack valve is closed. Positioning a pack switch to high causes the pack valve to increase pack output to a high flow rate. High flow is used when additional cooling and ventilation is required, or when additional volume is required for pressurization. If the APU is supplying air to the packs while on the ground, positioning one pack switch to high will automatically cause the APU to provide high flow. APU high flow provides a higher volume output than normal high flow. Such a configuration with both packs set to high will produce the maximum possible flow rate. With the pack switch in auto, pack flow rate is controlled by a system which selects the flow rate depending on pack switch position, air-ground logic, and flat position. In auto and both packs operating, each pack regulates to low flow rate. With only one pack operating and in auto, pack flow rate is regulated to high when in flight with flaps up. The pack will also produce high flow rate if it is supplied by the APU. Temperature sensors located downstream of the packs monitor internal pack temperatures and control the pack trip-off lights. Excessive internal pack temperatures will cause the pack valve to close and will illuminate the pack trip-off light. The corresponding air mix valve moves to the full cold or closed position. The air conditioning annunciator light and master caution lights will illuminate. The temperature selectors are used to set the desired temperature in the cockpit and the forward and aft passenger cabins. The temperature selectors have 2 settings: automatic and manual. With the temperature selector in the auto position, temperatures between 18 degrees Celsius, the cool setting, and 30 degrees Celsius, the warm setting, can be selected. The temperature selectors provide input to a corresponding temperature controller located in the E&E bay. There are 2 temperature controllers. Each temperature controller controls the corresponding set of air mix valves. The temperature controller receives temperature information from sensors located in the cabin ceiling. Placing the temperature selector in the manual position will provide the pilot with direct control of the air mix valves and bypasses the temperature controller. The position of the air mix valves is displayed on the air mix valve indicator. The valve position indicator will display the current position of the valves during both automatic and manual operations. In order to produce a colder temperature, hot bleed air must be removed by closing the hot air mix valve. Therefore, if the indicator points to the cold position, it indicates that the hot air mix valve is closed. Conversely, in order to produce a warmer temperature, the hot air mix valve must be opened in order to allow hot bleed air to be mixed with pack output. In this case, the indicator will point to warm, indicating that the hot air mix valve is opened. Air conditioning output temperature is monitored on the temperature indicator. The source to be monitored is selected by the air temperature selector. Supply duct selects the left cabin supply duct. The passenger cabin position monitors the passenger cabin. As discussed previously, A recirculating fan draws ambient cabin air and mixes it with the output of the packs. The recirculating fan is controlled by the recirculating fan switch. With the recirculating fan switch in the auto position, the fan operates at all times, except when both packs are operating and either pack is operating in high. Due to the heat generated by the flight instrumentation system, fans provide additional ventilation for the flight deck displays, such as the EADIs, EHSIs, and IRUs, the circuit breaker panels, and the E&E compartment. One fan, called the supply fan, ducts passenger cabin air around the instrument panels. The exhaust fan draws air from the E&E compartment, the center aisle stand, and the circuit breaker panel into the exhaust ducting. Each fan has an alternate. Together, these fans are controlled by the equipment cooling supply and exhaust switches. These fans provide a constant exchange of air. Depending on air-ground logic, this air is either exhausted overboard or into the forward cargo compartment. The direction of flow is controlled by the flow control valve. On the ground or in flight, at cabin differential pressures below 2.5 psi, the exhaust fan air is exhausted overboard. At greater cabin differential pressures in flight, the flow control valve directs the air to the forward cargo compartment. In the event there is no airflow for equipment cooling, the associated off-light will illuminate. The overhead annunciator and both master caution lights will also illuminate. Selecting the alternate exhaust fan should restore the airflow and extinguish the light. The air conditioning panel is set up during the pre-flight. Verify that the equipment cooling fans are operating and the equipment cooling fan lights are extinguished. Set the zone temperatures as desired. On the pneumatics panel, verify that the recirculation fan switch is in the auto position, the isolation valve is in auto, and the engine and APU bleed switches are on. Place the pack switches in the auto or high position. Notice the slight drop in duct pressure. Pack switches should be placed off to start engines. After engine start, position both pack switches to auto and the APU bleed switch to off. These switches remain in these positions until engine shutdown. During the securing check, the pack switches are placed in the off position. This concludes the presentation of the air conditioning system. The position of the air mix valves is displayed on the air mix valve indicator. The valve position indicator will display the current position of the valves during both automatic and manual operations. In order to produce a colder temperature, hot bleed air must be removed by closing the hot air mix valve. Therefore, if the indicator points to the cold position, it indicates that the hot air mix valve is closed. Temperature sensors located downstream of the packs monitor internal pack temperatures and control the pack trip-off lights. Excessive internal pack temperatures will cause the pack valve to close and will illuminate the pack trip-off light. The corresponding air mix valve moves to the full cold or closed position. The air conditioning annunciator light and master caution lights will illuminate.